Hello! How are you? Welcome to BrainTune YouTube channel. I am your friend, the TechTune. So, let's get started.
Hello, friends. Welcome to the BrainTune channel. Today, we will start the second part of the competitive programming tutorials. In this tutorial, we will see about working with numbers in C++. We will see how to represent various types of numbers in competitive questions. And we will also discuss various important points related to them. So, first of all, let's talk about integers. The most used integer type in competitive programming is int. Int is a 32-bit type with a value range of -2 to the power 31 till 2 to the power 31 minus 1. Note that if the type int is not enough, the 64-bit type long can be used. It has a value range of -2 to the power 63 till 2 to the power 63 minus 1. This point is very important because in competitive programming problems, we will be given the constraints for our input in the question, and on the base of that, we have to decide that whether to use int or long type. Because in many cases, it happens that when you submit your code, and in some test cases, the output can be so large that it exceeds the upper limit of int. In such cases, you will get a wrong answer. In such cases, long type will be used. Note this point. This is very important fundamental point. Avoid any wrong submission by taking in note of this point. We will see a competitive programming question related to this in the next video. The shown code defines a long variable in C++. So, we have our header file and the required code snippet as shown. Here, we declare a long variable x in the line 11. Then, we assign its value in line 12. You can see we can assign a big value to the long type. The suffix "ll" at the end of x means that the type of number is long. We can print it by using cout. A common mistake when using the type long is that the type int is sometimes still used somewhere in the code. For example, the shown code from the line 17 contains an error. We have an int and in another long variable p. And now p is equal to a multiply by a. And then we cout the variable p. This will give wrong answer. This is because even though the variable p is of type long, but both numbers in the expression a and a multiply by a are of type int, and thus the result is also of type int. Because of this, the variable p will have a wrong result. This is because the variable p is made to hold a long value. The answer is wrong, as shown, which gives some undesired negative value. This problem can be solved by typecasting, that is, by changing the type of a to long, or by changing the expression a multiply by a to long a multiply by a, which is obviously typecasting. This has been shown in line 18 of the code. Now, this will give right answer as shown. Usually, competitive problems can be solved using the type long. Do take note of the pitfall discussed now, as it can give general compile time errors. Now, let's see how to represent the decimal numbers in C++. They can be represented by using floating point numbers. In most competitive programming problems, generally, integers are used, but sometimes floating point numbers are also needed. The most useful floating point types in C++ are the 64-bit double, and, as an extension, in the G++ compiler, the 80-bit long double is also available. In most cases, double is enough, but long double is more accurate. We generally have to give answers to the problems to a certain decimal point and precision. The required precision of the answer is usually given in the problem statement. An easy way to output the answer to a certain decimal point is to use the printf function and give the number of decimal places in the formatting string. For example, we have a double R, as shown in line 27. And we want to print it to 5 decimal places. The shown code in line 29 prints the value of R with 5 decimal places and round it off to. Similarly, you can print to any number of decimal places that you want and can submit your solution. A difficulty when using floating point numbers is that some numbers cannot be represented accurately as floating point numbers. And there will always be rounding off errors. For example, in the shown code, in line 32, the value of double Z that we get as output is slightly smaller than 1, while the correct value would be 1. As shown in line 33, if we print the value till 20 decimal places, then it is less than 1, but the correct value should be 1. This is because of the precision and rounding off errors in floating point numbers that take place if we print the number to very high decimal places. Also note the next point, that it is risky to compare floating point numbers with a comparison equal to operator, because it is possible that the values are actually equal, but they are not printed equal by C++ compiler because of precision errors. As two numbers will be checked to high number of decimal places, and thus they can differ despite being equal to. A better way to compare floating point numbers is to assume that two numbers are equal if the difference between them is less than some constant e, where e is a small number. For example, in the following code, e is equal to 10 to the power minus 9. The shown code in line 41 shows how to compare two floating point numbers. So, if the difference between two numbers is less than this small number e, then they will be printed as equal. This can be seen in shown code of line 42. Note that while floating point numbers are inaccurate, but integers up to a certain limit can still be represented accurately. For example, using double, it is possible to accurately represent all integers whose absolute value is at most 2 to the power 53. Okay, friends. I hope you must have understood the topic. If you like our content, do subscribe our BrainTune channel and like and share it with your friends. Thank you. Bye bye.
friends. Please hit the subscribe button for more upcoming videos. And to share it with your friends. Goodbye, from your friend TechToon.